Hello, in this lesson, I want you to use the triangle inequality theorem to identify possible triangles. I want you to prove relationships using the triangle inequality theorem. Now, they're not going to be big, long proofs. They're usually going to be like one-step proofs. So you should relax about that point. The triangle inequality theorem says this. If you have a triangle and you have two sides, two of the sides added together, or the sum of the two sides, must always be greater than the third side. Now, why is that? Well, let's show you. So what I have here is I have this triangle, and I've measured the side lengths. And if you notice on the bottom there, I've got length A is F plus G. So in other words, if I take side AB and side BC and I add them together, I would get 9.6. Now I can adjust my triangle. I can make it bigger, I can make it smaller. Can I make this length smaller than 4.4, the length of side AC? Notice it's getting smaller here, and it's getting smaller and smaller and smaller and smaller. There it's 4.4. Can it get any big? Oh, it starts getting bigger, doesn't it? Well, of course, that makes sense. You're getting to a triangle. When it's equal to, it's actually not a triangle. It's a line segment. That's your segment addition theorem. That's why that works. So if you're given two sides, when I add those, they must be more than the third side. That's what's going on here. So in other words, if I give you any two lengths, if I give you like three matchsticks, can they form a triangle if we have certain lengths? Now let's take a look at example 1 here. On example 1, we've got lengths of 6.5, 6.5, and 14.5. So I always like to add the two smallest. So we're going to go, what's 6.5 plus 6.5? Well, that's 13, isn't it? 13 is less than 14.5. No matter what I do, I will not get a triangle out of these three lengths. So the answer is a big fat no. Let's take a look at example 2. Now notice I threw kind of a curveball at you. I didn't put them in order. So our three side lengths are 6.8, 7.2, and 5.1. My two smaller lengths are 6.8 and 5.1. Well, let's add them together. 6.8 plus 5.1. Well, I get 11.9. Notice 11.9 is greater than your third side, which is 7.2. So yes, this forms a triangle. Now, let's take a look at example 3. If I want to form a triangle, and two of the sides that are measured 7.2 and 5.2, what are the possible lengths of the third side? Well, I'm going to do exactly what I've been doing all along. I'm going to go 7.2 plus 5.2. Well, that's 12.4. In other words, I know the third side has to be less than 12.4. But we're making an assumption here. We're assuming that the third side is indeed the largest side. What if it's not the largest side? Well, if it's not the largest side, then that changes things around. That means 5.2 would be my largest side. Make that a little bit thicker for us, for me at least. So in other words, 7.2 plus something has to be greater than 5.2. Well, what would that... Well, hold it. I did that backwards. Sorry about that. 7.2 is my largest side. So let's put 5.2 in there. Where's my eraser? There we go. Well, what do you have to add to 5.2 to get 7.2? 2. So in other words, it has to be more than 2. So if I write this as an inequality, my third side is going to be between 2. Let me rewrite that. That looks terrible. Between 2 and 12.4. Now, do you see a shortcut here? Rather than doing all this work? The shortcut is add your two lengths to find the biggest side. When it can't, obviously it can't be 12.4. It has to be less than 12.4. Subtract your two lengths to find the smallest side. It's between those two. Now, it could be 2.001, but that would be an extremely obtuse triangle. Hope you realize that. So we're going to say it's between 2 and 12.4. Now, example 4 is a multiple choice. So let's pause the video, see if you can do this problem by yourself, then come back and check. I've got two side lengths of 6 and 9. So I'm going to do exactly what I just got to telling you in example 3. The smallest side is going to be 9 minus 6, which would be 3. It can't be 3, remember. The biggest side is 9 plus 6, which is going to be 15. So my third side has to be between 3 and 15. It can't be 3 and it can't be 15. If 3 is a choice, that's the one I want to pick, but it isn't. So which one of these is impossible? 4 is between 3 and 15. 9 is between 3 and 15. 12 is between 3 and 15. Oh, 16 is too big. So the correct answer in that one is 16.